Hey guys, today we're going to learn how to solve radical equations. So first we're going to start off with the square root equation. Here we have 4 over 3 square root of x plus 1 is equal to, now it says 1, it's supposed to say equals 3, just a side note. Now what we have here, this is the graph of the square root function, which is the left side. Equals 3, that is the horizontal line at y is equal to 3. Your solution is the x value where they intersect. So here the solution would be x equals 4, because that is the x value. Now if we look at this one, we have the square root of 3 over 2x is equal to 1/2 x. This one looks a little different. We have the square root function, again still in the red, that is the curve. But 1/2 x is a linear function where you have a slope, so that's why it's diagonal. When I look at my points of intersection, we actually have 2. If there are 2 points of intersection, then that means that there are 2 solutions. Here, our solutions would be x equals 0 and x equals 6. Now, what does this mean? It is possible for us to have one solution. It's also possible for us to have 2 solutions. And even though it's not pictured, it is also possible to have no solution. And if you would guess, we would have no solution when our square root function would not intersect with anything. So for example, if you had your square root looking like this, and then let's say a horizontal line down here, they would never intersect. So this would be an example of no solution. Now, I wanted to give you a graphical representation of what solutions to square root functions look like, but we are going to actually learn how to solve a square root function algebraically. So let's have a look at this example. Now I put here that because opposite numbers, positive and negative, have the same value when squared, when you square both sides of an equation, it may introduce apparent solutions that is not an actual solution. This is called an extraneous solution. In other words, an extraneous solution is an answer that you'll get to the equation that doesn't actually work. We'll talk about that when we finish this equation. So here we have the square root of x plus 5 minus 2 equals 1. And I have here steps that we can follow for us to solve any square root equation. Your first step is to isolate the radical, meaning we want to get the square root part all by itself on one side of the equation. So this minus 2, I'm going to want to move it over. So I'm going to add 2 to both sides. So now we have the square root of x plus 5 is equal to 3. That's step 1. Step 2 is going to be to square both sides. Now we square both sides because we want to get rid of the radical. And how to get rid of the radical is by squaring. So we square and then square here as well. The exponent is going to cancel the radical, and we end up with x plus 5 is equal to 9. That is step 2. Step 3 is to simplify. Now these 3 steps here, simplify, factor, and use the zero product property, we will talk about in the following example. This is more if we end up with an equation that is quadratic, but this is linear. So when you have a linear equation, meaning that x does not have an exponent, you want to isolate your x and just solve for it. So x plus 5 equals 9, we're going to subtract the 5. So x equals 4. Before I can confidently say that this is a solution, we will need to do step 6, which is check for extraneous solutions. And how we check is by plugging in the x value and verifying that the equation is true. Meaning I'm going to take this x and I'm going to plug it into my original equation. So I'm just going to rewrite it here so that we don't have all that stuff written on it. The original equation was the square root of x plus 5 minus 2 equals 1. So I'm going to take my x value and plug it in. So square root of 4 plus 5 minus 2 equals 1. We want to verify that this is in fact a true statement. The square root of 4 plus 5, that's the square root of 9. The square root of 9 is 3, and 3 minus 2 does equal to 1. This is a true statement. So that means that my solution is in fact x is equal to 4. Let's look at some other examples. Here we have 2 plus the square root of x plus 10 equals x. Just like in the previous question, the first step should always be to isolate your radical. So because this 2 is positive, I'm going to subtract it. So now we have the square root of x plus 10 equals x minus 2. Just like before, the following step is to then square each side so we can get rid of the radical. And that means that I have to square the entire side, meaning all of x minus 2 is going to get squared. The radical will cancel out with the exponent, so we get x plus 10 is equal to x minus 2 squared, which is the same thing as saying x minus 2, times x minus 2. So this is what I was talking about, that those 3 steps before are only when needed. The next step would be to simplify. So I'm going to distribute and combine all my like terms. So let's distribute this side. We get x plus 10 is equal to x squared minus 2x minus another 2x plus 4. Continue to simplify. We're going to combine these like terms. So x plus 10 equals x squared minus 4x plus 4. Now what we have here, this is a quadratic equation. When we have a quadratic equation, we are going to make equal 0. So that way, in order to solve, we would need to factor it. So subtract the x, so we can get rid of it from here, and subtract the 10. And that way, the left side of the equation is completely blank, making it equal 0. So this is the equation so far. X squared, negative 4x minus x is minus 5x, minus 6 equals 0. The next step from the previous slide is to factor. So now I'm going to find the two numbers that multiply to give me negative 6, but add to give me negative 5, which would be negative 6 and positive 1. So my factors are x minus 6, x plus 1. Then if we use the zero product property, which is the following step, that means that we set each individual factor equal to 0. So we're going to end up here with 2 solutions since we had 2 factors. My 2 solutions would be x equals 6 and x equals negative 1. Just like before I can say that these are in fact my answers, I will need to check them. So now I'm going to check for my extraneous solutions. Let's first plug in x equals 6. Now, just so I don't lose track what I plugged in, I'm just going to write down here x equals 6 so I know that that's what I'm checking. Now I'm going to plug it into my original equation. I'm going to erase this here so you can see what the original equation was. So everywhere you see an x, that's where we're going to plug in the 6. So 2 plus the square root of 6 plus 10 equals x, which I'm plugging in 6. So this is 2 plus the square root of 16 equals 6. The square root of 16 is 4, and 2 plus 4 does equal 6. So this is a true statement. So that means that x is equal to 6 is in fact a solution. Now I'm going to plug in x equals negative 1. So 2 plus the square root of negative 1 plus 10 equals x, which is negative 1. We get here 2 plus the square root of 9 equals negative 1. The square root of 9 is 3. Plus 2, we get 5. And 5 does not equal to negative 1. That means that x equals negative 1 is an extraneous solution, and we basically discard it. Just throw it away. It's not an answer. The only solution here is x equals 6. Now let's look at this one here. x plus 6 raised to the 1/2 minus 2x minus 4 raised to the 1/2 is equal to 0. When you see that exponent of 1/2, all that means is that it's a square root. Remember that the numerator is the power and the denominator is the root. And anything that has a root of 2 is a square root. So this can be translated, if you prefer to see the square roots, as square root of x plus 6 minus square root of 2x minus 4 equals 0. Now the first step is always to isolate the radical, but we have two radicals here. So I can still isolate them, but we're going to isolate them on either side of the equal sign, meaning keep one radical on one side and move the other radical to the other side. Because this one here is negative, I'm going to choose to add this one over. Although you could also subtract this one over. It does not matter which one you choose to move. I just prefer positive, so I'm going to move this over. So this is my equation. Square root of x plus 6 equals square root of 2x minus 4. The next step, as always, is to square both sides. And what's nice about these is that because we're squaring both sides and both sides are square roots, all that does is it's going to cancel out the square roots on either side. That's why we separate the radicals. So now this is what I have. X plus 6 equals 2x minus 4. And we end up with a linear equation. When it's linear, we solve for x. We isolate the x on one side. In contrast with when it's quadratic, we make it equal to 0 and factor. So I'm going to move all my x's to the left and my numbers to the right. So I'm going to subtract this 2x to move it over. And I'm going to subtract this 6 to move it over to this side. So that way my x's are combined here to give me negative x equals, and then my constants are over here, negative 4 minus 6 is negative 10. Divide by negative 1 to cancel out the negative. So x equals 210. And now I'm going to just double check that this is in fact a solution and not extraneous. I'm going to plug it into the original equation. I'm going to keep it as radicals. So the square root of 10 plus 6 minus the square root of 2 times 10 minus 4 equals 0. This is the square root of 16 minus the square root of 2 times 10 is 20 minus 4 square root of 16 equals 0. Two identical square roots that are being subtracted. They're going to cancel out, leaving me with 0 equals 0. That is a true statement. So this is my solution. So those are square root functions, square root equations. Now let's look at cube root equations. To solve a cube root equation, you do the exact same process as with square roots. Same exact steps. First step, isolate the radical. So I'm going to subtract 7 to both sides. So cube root of x plus 2 equals negative 2. Now here, instead of squaring both sides, I'm going to cube both sides because we square because the index of a square root is 2. So we want to apply the same exponent as the root. Here, this is a cube root, meaning the index is 3. So to cancel out this radical, I would need to apply the same number exponent. So that's why I cube it. That's going to cancel out the radical. So we get x plus 2 is equal to negative 2 cubed, which is negative 2 times negative 2 times negative 2, which is negative 8. Subtract the 2, and we get x equals negative 10. Now here, I don't need to check for extraneous solutions. This is going to be my answer. For the cube root equations that we're going to look at, there will always just be one solution. And here's why. All of the cube root functions that you're going to see, all of the equations, they're going to equal to some constant. It's not going to be anything more complicated than that. Any cube root function looks like this, like that weird sideways S. And a constant is always a straight line. no matter where you draw that straight line, you are always just going to have one solution. So all of these that we're going to see within our lesson and in your assignments, you will always have just one answer. You don't need to check it unless you want to, of course, check if you're right, but there won't be an extraneous solution. So it's a little bit simpler. Let's try that a couple more times. So now for this one, we have 2x minus 50 raised to the 1/3 is equal to negative 10. That exponent, remember that this just means that x minus 50 is within a cube root. So I'm just going to rewrite it because I prefer to see the radical. Now, the first step, isolate the radical. We have this 2 on the outside that is being multiplied, so I'm going to divide both sides by 2. Cube root of x minus 50 now equals to negative 5. Now we're going to cube both sides because we want to get rid of that radical. Cancel, cancel. We get x minus 50 is equal to negative 5 to the third. Negative 5 to the third is negative 125. Any negative raised to an odd exponent is going to remain negative because 3 negative numbers being multiplied will remain negative. And finally, we're going to add the 50. So my final answer, x equals to negative 75. One last time. Here we have the cube root of x minus 5 divided by 2 plus 1 equals 3. So the first thing, as always, isolate that radical. Work your way from the outside in, right? It's the reverse order of operations. So whatever is added or subtracted, we get rid of that first. So here, I'm going to subtract the 1. So cube root of x minus 5 over 2 is equal to 2. Now this over 2, that's being divided, so to cancel it, I'm going to multiply it 2. And that's going to cancel that out. So the cube root of x minus 5 is equal to 4. Now that the radical is isolated, I'm going to cube both sides to cancel it out. So now we have x minus 5 is equal to 4 cubed, 4 times 4 times 4, which is 64. In our final step, add the 5 over, and we get our final answer of x equals to 69. And that's how you solve radical equations, at least square root and cube root.